Hello everyone, welcome to this lecture. Myself Dr. Ranjana. This is the third lecture of the module 4, that is use of free energy in chemical equilibrium. In last lecture we have discussed the internal energy, enthalpy and first law of thermodynamics, right? And another form of energy is there, that is heat capacity, and we have discussed what is heat capacity, what is specific heat capacity and molar heat capacity. Then come to heat capacity at constant volume, right? Suppose there is a system, right, and Q is the amount of heat supplied to the system, right, and the temperature of system is raised by 1 degree Celsius or 1 Kelvin, right, and the volume of system remain constant, that is heat capacity at constant volume. According to first law, this dq will be is equal to dE plus pdV, okay, and when this change in volume is 0, then dq will be is equal to dE, and this heat capacity at constant volume is denoted by Cv, heat capacity at constant volume. Then by differentiating both sides by t, we can get dq by dt will be is equal to d by dt, and then dv will be is equal to cv dt. For finite change, this expression can be written as del E is equal to cv into T2 minus T1, that is change in temperature. This is the expression for finite change in any system, right? For a small change, this d will is equal to dE will be is equal to cv dt, and for finite change, this del E will be is equal to cv into del T, and for n moles, this del E will be is equal to n into cv into del T, right? That is n is number of moles, and this equation is important for numerical, okay? If you know the change in temperature and value of the Cv, then you can calculate the amount of energy, that is change in internal energy, okay? Then heat capacity at constant pressure, it is denoted by Cp. Cp is always greater than Cv. Why? Because Cp is the heat required to raise the temperature of a system by 1 degree centigrade, 1 degree Celsius, and also that heat is useful for utilized for work done. In case of Cp, it is the amount of heat required to raise the temperature of a system at constant pressure. If pressure will be constant, then work done will be there. Work done will be not 0, and then some amount of heat will be utilized in work done, and some amount of heat will be utilized to raise the temperature of the system, and due to this reason, this Cp will be always greater than Cv, okay? Then according to first law, this dH, this according to expression of enthalpy, this dH will be is equal to d plus pdV, and according to first law, this dq minus pdV will be is equal to d. If you put the value of T from the first law in the expression of this enthalpy, then you will get dH will be is equal to dq minus pdV plus pdV. Then dH will be is equal to dq, right? And by differentiating both side by t, we can get the expression for Cp. This Cp will be is equal to dq by dt, and this Cp will be is equal to dH by dt at constant pressure, and this dH will be is equal to Cp dt. Okay, for finite change, this del H will be is equal to Cp into change in temperature. Okay, and this del H for n mole, it can be written as NCP into T2 minus T1. If change in temperature and value of Cp will be known, then this del H can be calculated. Okay. Then come to relation between Cp and Cv. Cp will be always greater than Cv, but it will be the amount of energy by which Cp is higher, we can calculate it. This H is equal to E plus V. Okay. Then H can be also written as E plus RT, as PV is equal to RT for 1 mole. It is the gas law. Okay. Then dH will be is equal to dE plus dRT. If you differentiate this equation, then you will get dH will be is equal to dE plus dRT. Okay. And when differentiated with the temperature, then you will get dH by dt is equal to dE by dt, and R is a constant, then dt by dt. Okay. Then you will get this expression. This is the expression for Cp, that is this one, and this one dE by dt will be is equal to Cv. Then Cp will be is equal to Cv plus R, where R is gas constant. You can find the value of Cp if you have the value of Cv. Okay, this expression is also important. Cp is greater than Cv, and how much it is greater? It will be is equal to Cv plus R. Then come to next thermodynamic function, that is entropy. What is entropy? Let's discuss that. Entropy is a measurement of randomness or disorderedness of the molecule or atom in any system. Greater the randomness or disorderedness, higher the randomness present in the system, higher will be its entropy. It is the measurement of randomness, okay, disorderedness of the molecule in any system. As we know, the liquid when the liquid convert it to gas, the entropy of liquid will increase because the disorderedness of the molecule will increase on in phase change. Okay. Then come to characteristics of entropy. The symbol of entropy is S. It is denoted by S. Okay. It is a state function. You know that. What is a state function? This entropy depends only on the final state and initial state. It does not depend upon path. That is, del S will be always is equal to S final minus S initial. Okay. Then this entropy is extensive property. It means it depends upon amount of substance, amount of matter present in the system. Okay. If you change the amount, entropy will be changed. Okay. Then the entropy of gas will be always higher than liquid, and entropy of liquid will be higher than solid. Okay. Because disorderedness of the molecule in solid will be less than liquid, and in the liquid it will be less than gas. Okay, you know that fact. Then the third law of thermodynamics is also related with this entropy term. What is third law? The entropy of a pure perfect crystalline substance is zero at absolute zero of temperature. Okay, the both second law and third law is related with entropy, can explain in the term of entropy. What is second law of thermodynamics? The entropy of universe increasing constantly. Okay, try to increase constantly. Entropy of universe will always increases, and the entropy of a pure perfect crystalline substance is zero at absolute zero temperature. These are the second law and third law of thermodynamics, right? What is third law? The entropy of perfect crystalline. What do you mean by perfect crystalline? Entropy of a pure perfect crystalline. As we know, the disorderedness of the molecule or atom in solid is less than liquid. Okay, in crystalline solid, this disorderedness is much less, and in perfect crystalline solid, these molecules are fixed at that position, but they can vibrate. The disorderedness is minimum in perfect crystalline solid, but there is vibration of these molecules. This molecule can vibrate at their place, and this vibration will stop, or you can say that the atom or molecule present in the substance freezes at absolute zero. At absolute zero temperature, this molecule can't vibrate. इसका मतलब at T is equal to 0 Kelvin, absolute means 0 Kelvin. At T is equal to 0, temperature is equal to 0. At that 0 Kelvin, the entropy of a pure perfect crystalline substance will be 0. Okay, and second law is entropy of universe is increasing continuously. The SI unit of entropy is joule per Kelvin per mole. For reversible process, the total entropy change of universe is 0. The total entropy change of universe is 0. It means change in entropy for system will be is equal and plus change in entropy of surrounding will be 0. It means if you increase the entropy of a system, then entropy of the surrounding will decrease. Okay, for a reversible change at fixed temperature T, if reversible change takes place at a temperature T, the change in entropy, that is del S, will be is equal to heat energy absorbed or evolved divided by temperature. Okay, this expression is applicable for reversible change at fixed temperature T. Okay, if del S will be positive, entropy increases. Then when del S will be negative, entropy decreases. Then for reversible isothermal process, if Q is the amount of heat absorbed from the surrounding at temperature T, then del S of the system, that is change in entropy of the system, can be given by Q by T, not Q by del T. Q by del T is heat capacity, but Q by T is the change in entropy. Okay, this system absorbed Q amount of heat at temperature T, then it can be represented by del S is equal to Q by T. And surrounding loses same quantity of heat. If it will be absorbed by this amount of heat absorbed by the system, then it is the surroundings loses same amount of heat, and then del S of surrounding can be given by minus Q by T. Minus sign shows that heat was given by surrounding and absorbed by system. Then del S system plus del S surrounding will be 0. This Q by T minus Q by T will be 0, and total entropy change for the universe will be 0. This is the case of reversible isothermal process. Okay. Then come to irreversible process or natural process or real process. A system of lower temperature T1 can absorb the heat Q from the surrounding. This system can absorb amount of heat, this amount of heat, that is Q amount of heat, only when this temperature of T2 will be higher than T1. It is fact. If temperature of system will be higher than surrounding, then heat will evolve, not absorb. Okay, it will absorb by the system only when this T2 will be higher than T1. Okay, then this del S of system will be given by expression Q by T1, and del S of surrounding can be given by minus Q by T2. Okay, the temperature of surrounding is T2, temperature of system is T1, then it can be given by these expression. Then del S will be is equal to Q by T1 minus Q by T2, and del S can be given by this expression. And when T2 will be higher than T1, then del S will be always positive, and this is the expression for second law. For irreversible spontaneous process or natural process, the entropy of the system and surrounding increases continuously. The entropy of universe, that is entropy of universe, increases continuously, tends to increase always. Okay, this is your second law. That is del S for irreversible process will be always higher than 0. Okay. In next class, we will discuss this entropy change for an ideal gas. Entropy depends upon temperature, pressure and volume, and how this entropy changes with variation of temperature, pressure or volume in the any system. Okay. Thank you very much. Have a good day.